Hello friends, myself Professor Vinod Pillai. I'll be teaching you basics of C language. I've divided my sessions into multiple parts. Today we'll be taking the part 1 of my session. In this session I'll be teaching you basics of C language, need of variables, operators and decision making. We even call it as control statements. Okay, let's begin the session. Before getting into the session, you should know that for any programming languages to work, we need the libraries. In C, as I'm using Linux, I've already installed the libraries into it. If you're using Windows, you'll be using an IDE called Turbo C, which is having inbuilt libraries in it, and plus it's an editor. As I'm using Linux, I'm not having any editors. I'll be using my text editor only. Okay, let's begin it with a simple program and I'll explain how it works it out. Okay, so this is my program. I'll explain you each and everything, why I've included it and what is the need of it. We'll just create a simple hello world program and we'll try to save it. I'm trying to save it in my desktop. I'll name it as prog1 prog.c, the desktop, the C programs, and save it. Now if you see it, I've saved my program with a name called prog1.c. Each and every file has two parts, that is the file name and the extension part. In C, the extension is .c, like in C++ is .cpp, and in Java is .java, and in PHP it's .php. So same way in C language the extension is .c. Okay, now what is all this about? Okay, now the first statement which I have included is an std.h. it's a header file. Now why I need a header file, I explain it. And second, this is the main method. Okay, and why I need the main method also, and what is this doing here? Okay, let's put it in slash in here, and let's put it a slash in here. We'll come to know it. Screen. My task is, for any program you should do, you should have a task. In my program, my task is to print an hello world in my display screen. Okay, let's see whether it's working or not, and then I'll explain it why I've written all the statement, how it's working out and all. To run the program in Turbo C, it's quite simple. You have to compile and you have to run it. In Linux, it's a little bit, you have to do it, that is you have to compile it. I'm getting into my desktop because I've saved it there. ls, I'm going to my C program files, and there I can see my file has been there. Okay, now how to run it? cc prog.c -o prog.out. I'll explain that also why I've done it. Let's see first whether the output is coming or not. Good, I'm getting the hello world. That's my task has been done. Now how it's been done and what is I have done it. Now any program to start it, it requires a main method. A main method will work something like a starting point for a compiler to check, and a starting point from where the program will start executing. So each and every program requires a main method, and it requires only one main method. Okay, you can't have more than one main method in C. At least in Java it's quite possible, but in C you require only one main methods, from where the compiler will get an idea from where I have to start executing it. Okay, so I got an idea that I need main method compulsory for each and every main method in each and every program. Okay, except if you're creating an header files. We'll get into that, what's header files and how to create your own header files and all, but time being we are creating our program, we want it to be executed, we want it to get an output, we need a main method. Main method begins with the curly braces and it ends with the curly braces. That's the scope of the main method. All the variables, methods, everything written in that only. Okay, let's get into the second point. Now my task is to print something on the screen, and now to do something to print on the screen I don't have to do much task, because in C library it's already been written a function. Now what is a function, we'll come into that, but just a brief introduction right now is that a function will act something like it is a already been done, some task is there, I want to repeat that task. I'll not start from the scratch, I'll call that particular function and it will do all the tasks for me. Okay, so here the printf is the function, it's an inbuilt function. Okay, and I want to print hello world, so I put hello world in there. Slash n is a specifying that I want to put a new line, so I specified slash in front of the hello world and after the hello world also. Now whatever you want to print on the screen, put it in the double quotes. It will be directly be printed on the screen only. Okay, now if you are using an inbuilt header file, I mean inbuilt function like the printf what I have used here, you require some things to be known. That's one thing is like you should know the function name, that is how it is being created, what's the spelling and all. You can't make spelling mistakes like printf or print or something. You have to write exact name. Okay, so I know the function name, and the second rule says that you should know where exactly the original function is being written. That's the what is the header file. So that's why I've included stdi.h, because a printf is a function, inbuilt function written inside the stdi.h. So it makes sense that include stdi.h I've written because I want to use printf. If I don't want to use printf, I don't have to include the stdi.h. Now stdi.h is a header file, that's why its extension is .h. It's simple, a C program only, but it's not having a main function, a main function. It is having only the functions which is to be used by the users, so it's having an extension .h. So I have to include in my program, I have to write hash include stdi.h. okay, then comes my main method, curly braces, the printf, and my statement. So here it makes sense, whatever I've written here goes in this sequence. Okay, and to run it, what I've done it basically, after saving the file in .prog.c, I have to run it in Linux. I have to do a little bit task. cc is the compiler, I'm telling it to compile my prog file.c. -o is to telling him explicitly to generate an output file name which I am specifying it. If I write simple cc prog.c, the C will generate, the Linux C will generate a out file but name as a.out. But I want my output file a specific name, then I have to specify -o and the file name, that is prog.out. That's done, and if you see that it has generated my output file and it's there, I can see it here. Okay, so that's why now for once I want to run it, I have to simply write prog./prog.out and it will give me the output. Always remember, if you want to add something like that, I want to display hello world twice, so I have to write this statement once again. So I've done it, but always remember, after making changes, if you directly run it, you'll still get the same, the old output. You have to compile the program once again and then you have to run it, then you will see that you will get the output. Okay, so we have completed the first one, that's lesson 1, that's basics of C language, why you require header files, simple hello world, printf statements, and the comments. Okay, comments is quite important in the program. What comment does is basically is to add some special meanings or special statements so that programmer or the anyone, it's quite easy to understand. Like I have put in front of the main method, that is like what is this particular method is doing or something like that. Comments are, there are two types. Comments can be done in two major types. One is single line comment, that is what I have done it. Okay, and second is multi-line comment, that is something like this. You put a slash, a star, and a star and a slash. Anything which is written in between this all goes into the commenting statements, like something like that. Okay, always remember that comments will never be generated in the output, so it will have no effects in the output and will not affect in the even the compilation time also. That is, if you input multiple comments, it will not affect the output time. So don't confuse. Comments is always good. Use it for proper syntax. If you want to put extra informations or something like, you should use comments. It is a good coding practice. Okay, so we get into that also. Okay, so comments, how to run it also we have seen it. Now let's get into the second topic, that's variables. Why I need variables and what is the need of variables. Okay, and what will be a variable is. Okay, now if I simply want to display hello world or something like that, that's fine. Now someone says that I will give you two numbers and you want to process it on that number and something like that. Now if he gives some number or something, then I need some locations, some place where I can store that number so that I can process that number and all. For that I require variables. Okay, so variable has two parts, that's a data type part and a name part. Okay, now the data type is like, now the see what they have done is like, if you need a variable, then you should specify to the memory, or before telling the compiler to allocate that particular memory, you should tell him what type of value you are planning to store in that particular variable. You want to store an integer, you want to store a long integer, you want to store a floating point value, or you want to store a character or something like that. So that's the data type will play. There are different types of data types available: integer, float, double, depending upon the situation we can use it as per our needs. Okay, the name is quite simple. You can put any names into it. There are certain rules and regulations. You can't have a character, you can't have a space, and all those things. That is quite easy to remember. So you declare the variables you need it. So as I have declared I as a variable, I can store some values like integer because I have put its data type as int. Now to print the values into it, I have to simply write printf the answer. The value is %d and I. Now what's this %d doing here? Now there is a special type of printf. I don't want to simply print an hello world. I want to print the value of I. To do that, what I have to do is like I have to tell what value I want to print. I want to print I. That's fair enough. Now I have to specify what's the data type of I. So I have to specify it by %d. That's a symbolic way I have to represent that what is the data type of it. So I have specified it. Let's try to compile it. It's compiling, it's compiled, and let's see it, and you will see that there is the output that the value is 100. That's as simple as that. In the similar way, I can declare float, I can declare double, and I can declare long integer, or even I can declare character. So you have to remember quite things like that. Each and every variable has its own symbols like %c for character, f for float, and similarly %d for integer. Okay, you can have any of them and you can just simply print them. Okay, we have seen now what's variables, different types of variables. Let's get into printf and scanf. What's the printf and scanf is doing here? Okay, now if you run this particular program, I don't need it. Okay, if you run this program, you'll see that each and every time you run the program, you'll have I as 100 only. Now user does not want that. User says like I should have a value which I have given him at runtime, not the value as the compile time only. So you require something like this I, and if you simply, okay, remember this one thing I forgot is like if you declare a variable without giving any value, it will have a garbage value. So if you try to compile it now and you run it, and if you say this value, this is something what you are not expecting, but it is because you have not assigned any value to I, and it will have a garbage value. So it's better practice to, if you don't want to do it, you can put it initialized as 0. Now to get the value as runtime, what I have to do is enter the value. That's a message I want to give to the user. User will get this message. I have to use scanf %d %I, and to see whether the value has been there, I just again use the answer is I'll explain, don't worry what I'm doing. Let's put a slash in here, and let's put a slash in here also. Let's see whether it's working or not first. It's been compiled, that's good. It's asking me the value. I'm telling it I need 20, and the answer is 20. So the value I'm giving at runtime to I, it is being initialized to I, and it is being giving me the output also. Now what I've done is to get the value from user at runtime, you have to use a inbuilt function called scanf. It's same as printf, but it does something different. In scanf, it will wait for the user to enter a value. Whatever value is entering at the screen, it will be got from the keyboard. It will be transferred to the variable. Now to the variable, you need some things like scanf says I need some information like what is the data type of the variable, which variable you want to store, and where is the variable in the memory. To do that, we have to specify all three of them. If you look at carefully, %d is the data type. I'm saying the I's data type is %d. The variable where I want to store, that's I. Now where in the I is stored in the memory, I don't know, but to get an address of any variable, you have to just simply put ampersand in front of it. So scanf does all those things for me. It's so simple. Now the same, because it is an inbuilt header file, I have to specify the header file also. This as kind of inbuilt function, so its header file is nothing else, it's same as stdio.h, so I don't have to specify any other header files. Now simply to print the value, I've used again the printf. The answer is %da and /n and I, and you've seen I've done it. It's quite easy. Now let's get into the second topic. Next topic is symbolic constant. Symbolic constant is something like a constant, you can create it. A constant is a variable whose values you don't want to change in complete program, so you can do it that by defining it hash define n as 100. Now here in this program, if you see that n became a constant. A constant is something whose value you don't want to change. It's something like a best example is pi. Okay, you can it's been compiled and it's asking me the 33. If you see, the constant value has been there. So what I've done is, like, there are some rules for declaring a constant, that is hash defined is then you have to declare it in front of a constant name, and it's not compulsory. You don't have to specify in data types, that's compulsory. What I'm saying is, it's not compulsory to have a constant name with a capital letter only, but it's a general practice. That's it. So it should not be confused whether it's a constant or it's a normal variable. We keep it as a capital variable. 100 is the value I want to assign. There will be no equal to sign, there will be a space in between them, there will be no data type, there will be no semicolons. That's quite things you have to remember. It's one of the ways you can declare a constant. Now the thing which I want to tell what is constant, it will be quite easy. If you see that I have declared I as 100 and that's constant, I now want to change the value, it will generate an error according to me because it's a constant. Let's see whether it's happening or not. Now it says like that the L value requires a left operand of assigned. It's an error, so you can't assign a value to it because it is not possible, because you have declared it as constant. That's what all constant says about. Will not be able to see the fourth session that will be taking in the part 2 only. I don't want to get you confused. I think so. It's fine. I think so. I can take it. I'll just give you an idea of operators. There are different types of operators available. That is, you can do arithmetic operations, less than, equal to. That's relational. Logical operators are there, but we will see it as and when we require. In the decision making and control statements, it's quite easy. In that, it will be mixed up, so it will be easy for us to understand that only. So I don't want to get into operators right now, but it's quite common that we can do all those things. That is, someone says I want to give it two values, you can do an addition or not. Okay, I, j and sum, and I can get a value of I. Similarly, I can get a value for j, and I can simply write sum is equal to I plus j. That's it, and just simply print the answer. That's compile the program. It's asking me value 30 plus again 30, so it's getting 60. So what I've done is simply I declare three variables because I three variables are required, one for I, second for j, and I want to combine it and I want to get the values and sum it up. I declared a third variable, sum I is equal to I plus j, because arithmetic operations is possible because it is one of the operators being available. Similarly, you can do multiplication, division, and all those things. That's what I was telling. We'll get into all the other operators later on because it will be coming in again and again in the programming sessions. I just want to highlight there are different types of operators. There are I'm sorry, quite other types of operator also available, like bitwise operator and all, but for timing you should know that this many types of operators are available. Now let's get into some of the good things about the programming languages, or one of the important things, that's decision making. It's something like real world problem, something like that. If someone says like, if I want to go to an interview and someone says like, if you want to get into the interview you should get minimum of first class or something in your masters or something like that. So that's basically, I put some person on the gate and say anyone who comes with a mark sheet, just check it up whether he's having a master's certificate with a first class or not. You will check it, and if I'm not having, he will give me an appropriate message, sorry, I can't enter because you are not having the minimum requirements. And if suppose he's there, he will say, welcome sir, you can get into the interview. Now this is quite possible in real life, but how can we do those such tasks in the programming? That is quite possible with the help of conditions, or you can say control statements. There are four types of control statements: simple if else, nested if, and if else ladder. Let's get into one by one. Okay, I have a variable called I. I'll ask the user to enter an I, and if suppose I's value is, if I less than 10, then I'll want to print some message, printf sorry, not allowed. Okay, now how is this going to work? What is happening? Okay, now if is quite simple. I'm asking a value from I, it's entering the I's value, it's printing it up, and the if works something like a true part. Okay, whatever value is I, it checks with it, and if it is there, if this condition is right, then this will be executed. If it is not right, the next, that means it will not get into the if condition. Okay, let's save it, let's check it out whether it's working or not. Compile it, I run it, and it's asking me i's value. If I is less than, okay, let's try 5, and says sorry, not allowed. Let's again run it, and this time I'm entering 20, so it gives me no output. Okay, so basically this is a true part. It checks the condition, whether it is true, it will get inside the last. Now let's do something like this way. No, this is not quite fair. I want to give some message to the person, and this is the example of simple if. Okay, if the value is less than 10, it will give the message. If it is not, I want to print a message called good. So if it is a value is greater than 10, it will print a message good, and if it is less, it will say sorry, not allowed. Let's again compile. Sorry, I forgot the T. Just compile again, let's run it, and now this time I'm writing 20. If you remember, the last time in the 20 it was not giving any output. Now I'm writing entering 20, and it says good. So this is what it is if and else something works like a false part. So we have seen a simple if where it is only if condition, there is only true part, there is no false part. And if I want to handle the true and false, both the conditions, then I have to use if and else part. Now what is nested if? Nested if something like that in an interview, if someone says I put a person on the gate and ask that person who is entering, he should have minimum first class in the masters, so that's simple if. Now, and if suppose if I put another person, once he get into the gate, there is another person who is checking his J marks or something like his max marks. If he's having max more than 20 or 30, then he'll say like you are already been selected in the interview or something like that. So it is quite possible to have any number of if inside another if, or any number of if else inside the else part. So I'm asking him printf great. I just want to print that message. I don't just want to show you that it's quite possible. So this printf, I'm right now I'm removing it. I'm putting this printf and scanf inside inside this. So it goes something like this way. User comes, I ask him the enters the i's value, he enters the i's value, then I ask him the j's value. If he enters j's value, and if you see it carefully, this is simple if, there is no else part. Okay, let's save it. I forgot the bracket here. Save, and let's compile it. It's working. It's asking me i's value. I'm entering i's value less than 10, so that's there. Now it's asking me exactly the j's value. If j is less than 20, so I'm entering 12, so it's printing the grade. That's what it is all about. Now if else ladder is quite a special type of if else. It's basically been used in the conditions like something like a percentage or something. If his percentage greater than 20, greater than 80, then he's high distinction. If a person is greater than 70, he's having distinction. If his percentage is greater than 60 or something like that, first class. And this way, if you want to print something, then you can, it's better to use if else ladder. Go something like this, else if I greater than 80 or something, you can print any of them. If I is greater than 80, then this is the one. If I is else if I is greater than 70, you want to have this one. Just copy it. So in this way you can have multiple of them. If any of them matches, it will go into any of the one of the loops. Okay, so in this way you can have it, and at the end, if nothing matches, you can have else. That is, if nothing matches, it have to simply go to the else part. But always remember in the condition that any time only one of the if condition will end. It will never happen that an if is also executed and the same time you are able to execute the else also. I'm not talking about nested if, I'm talking about a simple if and else part. If it is if it has went to if condition, it will never went to its else part. Okay, I think so we have covered most of them. We have completed the first part, that we have seen the basics of C language. We have seen why is the header files required, how to create a simple program, how to run it, how to compile it. what's the requirement of the comments and all, what's the need of variables, different types of variables, operators what are available, and the decision makings. There are 4 types of decision: simple, if else, nested if, and if else ladder. I hope so you have understood my basics of what I want to explain you of C languages. Let's In the next session I'll be explaining in the part 2, and we'll be seeing further parts, loops and all those things. Wait for my next session, and thank you very much.